What is up, nerds? Hansi here. Good morning to you. If it's morning to you, I guess. It's morning to me at least. Today we'll be going through the code for the music reactive desk light. I asked you in the video if any of you wanted a walkthrough on the code, and the response has been quite huge actually. Many of you wanted to make a go through or a walkthrough, on the code. So I think we'll be doing that today. First, I just want to start out by saying that I might be doing these videos in the future where I go through the code in more detail for one of our projects. This will not substitute or reduce the amount of project we do on a general basis, but it will be something extra. And I think I'll make it Patreon only videos, so only our patrons, no matter how much they give though, can see these videos. And it's mainly because it's a lot of extra work. It still will be, the code will always be available for free and for everybody on GitHub or wherever. So yeah, just wanted to say that. So we can start by going to GitHub and check out the code really. So it looks, I guess it's not that long, and 50 of the lines is just an imported function from the Arduino website itself. Just stole it selflessly. Shamelessly, selflessly. I stole it shamelessly, but I think I've credited somewhere. Yeah, imported from the Arduino website. Yeah, anyway, so it's about 240 lines, and it's not very complicated really, but I guess it can look, it's a little bit strange, or I'm not sure if the comments are explanatory enough. Anyway, I think we'll begin by creating a simple version of the code, and we can come back to this and we can look at what differences or what extra things I have implemented in this code compared to the one we'll be making. So we go to our Arduino IDE, and yeah, one of the things that you should have set up by now is the fast LED library. If you don't have, just Google fast LED and you will get to their GitHub, and you can see how you can install it from there. If you have installed it to Arduino and you go to include library and you press fast LED, they include all sorts of libraries for you. I guess they're all sub-libraries, or at least libraries from the fast LED library, but we only need the fastled.h file. There we go. So we'll start by defining some constants or some macros. We need one for the LED pin that we'll be using. This is the digital output pin, and this is the one that controls our LED strips. It goes to the individual addressable LED light. And then we have the sensor input, which we'll call analog read. And it's basically the pin that we connect our sound detector to. Another thing we need is the amount of LEDs. So let's say, I think we use num LEDs, yeah. That's about 50. This value is whatever, like all these values depends on your own implementation. So if you chose another pin, change this and this, you understand. And this is also based on how many LEDs you want to use. You don't have to use 50, you can use like 10, 200. Just make sure you have a power supply that can handle 200 if you go for that. Okay, fine. Let's continue. We need a variable. This is a fast LED data type, CRGB, and it contains basically an RGB value of the color. And we can use this to set the color of every LED light individually. Hence, individual addressable, right? So we call this LEDs. Oh, sorry. And we'll make it num LEDs long. That's great. So in the setup function, which runs when the Arduino starts, we can write. By the way, I will assume that you have some knowledge of programming and some knowledge of like Arduino in general, because I might make a video tutorial on that later, but there's already so much on it, so I'm not sure how useful it would be to you, really. So we start out by using the fast LED function. that adds our array of LEDs and marks them as fast LED LEDs, basically. So we tell it to be neopixels, which are individually addressable, and then on which pin we're gonna use those. And then we say which variable contains our LEDs and how many there are. Okay, so that's the first strip. So that's basically, now it's basically set up, but you still won't see any color or anything change on the LED strips yet. So let's start by setting a color for the LED strips. We can just do blue. We're just gonna loop through everything, a basic for loop, using the numLEDs macro and incrementing I every time. Okay, so then we can just access each and every element of this array, and we can set a CRGB value, which is also, you know, a fast LED function. This function takes 3 parameters, and it represents the different colors. So you have R, G, and B. And by setting all 0, you won't have any light. By setting the red value to 255, which is the max value, you'll get a completely red light. If you add some blue, you'll get a purple. Yeah, you get it. And that's basically for setting a static color. So let's see what's wrong here. Okay, LEDs was not declared in the scope. I forgot to add a semicolon. Okay, great. So yeah, I cannot upload a code because I don't have the lamp with me right now. LEDs. Okay, great. So this compiles. Sorry for that. But you know, programming, these things happens all the time, really. Okay, so we have given every element a color value, but we haven't told the LEDs to show yet. They have to be told to kind of set a value or to display their color. So if you have connected your LED strips and that's all you have, this code should actually work. You could just upload it right now and you will see that your LED strip should be red, really. Yeah, no magic here. Okay, so the next thing we have to do is to make the LEDs dance to our lights, right? We need to read a value from the analog sensor, and basically this value will decide how many LEDs we're gonna be showing in the final product or in the final lamp. We use the built-in Arduino function analog read, and then we get the macro analog read, which takes the pin 0. Okay, so this should ideally output a value from, let's see, from 0 to 700. No, I'm sorry, from 1000. From 0 to 1024. But I had a problem with the sensor, and well, I'm not sure if it's supposed to be that or not, but it only made a value to 737. You should check that out by dumping the value to a serial output. And this is ultimately what decides what we're gonna do with the LEDs. This is everything we have. So we have to use this value in clever ways to change the color of the LEDs or to change the amount of LEDs that are shown, really. But then again, I'm just gonna show you a simple version of this code, I guess. So how many LEDs do we have? We have 50 LEDs, right? I'm saying LEDs, but yeah, I mean LEDs. But you know, in Norwegian we say LEDs. Don't know if that's common for any other countries. So basically we have a value from 0 to 737. And we have 50 LEDs. So ideally we want to map these values, the values from 0 to 737, to values from 0 to 50, right? Because then we can decide how many LEDs we will show based on the sensor value. So if you've been using Arduino before, you've probably also seen the map function. Let's call this one show LEDs. And we call this map. And then we call it on the sensor value. And as I said, mine goes from 0 to 737, but I'll be using 1024 as that's 23, I mean, as that's more the default sensor, analog sensor inputs. Yeah, and we'll map that to 0 to 50. So what this basically means is that any value from 0 to 2023 will basically be represented by a value from 0 to 50. So for instance, 1 will probably be 0, and the value 500 will probably be mapped to 25, or it will be mapped to 25. This lets us create another for loop. And we can loop through all our LEDs again. I'm sorry about mistyping a lot. I recently changed from Norwegian to American keyboard, so this is why. And then we'll go and say that if I is less than show LEDs. Okay, this says that if we're in the loop and we're visiting a LED that has index that is lower than the amount of LEDs that we have mapped, right? Then we can set a color. So we can set them to red, for instance. Sorry, we need to, of course, we need to access the index. Like this. Great. Does that make sense? So basically we say if the sensor value is 500, okay, that means a semi-high sound. Not too loud. So 500, just in the middle. Then we want half of our LEDs to show. Then 500 is mapped to 25, okay, in this variable above here. And then, oh, not 50, 25. And then we go into the loop, and this I value goes from 0 to 50. And when this one is below 25, we will set the color of these LEDs. Make sense? And if not, if the value is basically if it's higher, then we can set the value to nothing. Oh, 255. So we set them to nothing. And this means that if we had a higher sound earlier and now we have a lower sound, we will basically turn off these LEDs. This creates the effect that we have a sound reactive light already here. We actually do. So what do we not have here? Well, we don't have any way to. This is gonna be very harsh. So for every time we run the loop, we should also probably to like spare some cycles or whatever, we could add a 5 millisecond delay here. Won't matter to us. We won't be able to see the difference anyway. Okay, so but yeah, as I said, this will probably be pretty rough. When you look at a light, it will change very quickly, very abruptly, and if you have any false readings from the sensor, which happened a lot to me actually, every fourth or maybe even every third value was quite a bit off from all the other values, and it didn't make sense with the actual sounds around me. So I don't know if that's because the sensor is cheap or if I did anything wrong. You can tell me if you have the same issues. But basically, I think no matter how, you're gonna get bad values from time to time, and this will really kind of display in this type of code, because you have no check for a bad value and you instantly change the light based on it. So if it reads 0 when there's a high sound, it will go black for just a fraction of a second, but still, if it does that a lot, then it will be visible in the end. And yeah, we only have one color, so there's not really much going on. The color will jump up and down, but it won't really do anything. So in a sense, it is basically the exact same code, but it's a little more elaborate, and it does other things based on the sensor readings as well. So one thing I just want to get out of the way is that we have a function called fscale in the bottom. This replaces the map function that we have used in the code we just wrote. It's basically the exact same function, with the exception to that it has another parameter, which makes it not a linear map. It's more like a curved map. So this can give us the chance to make the LED lamp or the LED lights react stronger to louder sounds, and then, for instance, less to lower sounds. I think that was a nice effect anyway. Yeah. So first off, we have a million, not a million, but we have quite many new macros here that we introduced, and they are kind of self-explanatory when we go through the code. We won't be looking at the variables too much. It's in too much detail, I think. You'll figure out this on your own. We can start in the main loop, which is here. So this is mainly created because I thought that I would have different modes on the lamp, which I never got to implement. And all it does now is to call the visualize music function. So we can jump right to the visualize music function. Okay, so here we see the same sensor value, the read, that we did before. Then we have a check that if it's 0, it should basically never be 0. Under normal circumstances, there will always be some kind of noise, some kind of sounds, background noise, anything really, just static. And yeah, I will consider a reading that is 0. I will consider that a bad reading. Then we create a value, a mapped value, using the fscale function that I just talked about, which is basically map. Then we have an average, which is an array, and this function here just computes the average of that array. Okay, and this average array contains readings from past loops, like previous readings of the sensor. And if the sensor value that we just read deviates too much from the average, then we discard that value as well. We just jump out. And if everything is fine, then we insert the new value in the average, and then we have another average as well. It's a longer average, and it takes basically a longer time window when it calculates the average. So we have a function that's called check high. I'll go back to that later. I'm just gonna go through the rest of the code here in this function, because we're basically almost done. This last for loop here is basically the same for loop that we made. This for loop here, it does the same function, but it uses the variable Kershaw, and this variable is also basically the same map as we did before. So it decides how many of the LEDs that will be displayed and how many that will not be displayed. But there is a major difference here, and if we go to the actual code inside of this loop, we can see the difference a little more clearly. Because here in the code that we just wrote, we set the LED value to a specific value, which means the change is instant. It goes from 0 to a bright, or from bright to 0 in one of the loop cycles. While in this code, we go through each of the colors individually. So for instance, if the LED we are at is lower than the Kershaw, it means that we are going to change the value of this LED light now, because it's in the range of the sound that we want to display. And then we check for sanity values. So we check that the value that is already displayed on the red value, the LEDs on index I dot R, which gets the red value on that LED, plus color dot R. Okay, so what is color dot R? Color dot R is a struct which has RGB, and it is defined by setting an integer value. This is updated based on what color we want. So you can see we have something called song mode here, song mode high or song mode normal. These song modes are basically set by this function check high. We'll get back to that a little bit later. It's the last function I'll be going through. But based on what mode the program has detected that the song is in, for instance normal, then we set the color.r to be -1. Okay? This means that for every time we enter this loop and we are at an LED that we want to change, then the LED value plus color R, which basically is -2 now, -1 I mean, as long as that is bigger than 255, we set it to 255 because we don't want a higher value than 255 because 255 is already the highest value. The same thing counts for 0. 0 is the lowest value, so if it's lower than 0, then it's 0. But if it's in between 0 and 255, then we do that LEDs I.R, which is the red value of the LED we're at, equals to the value it already has plus the color.r value, which is -1. This means that every time this LED is in the loop, it will lose red value. If it had any red value, it will lose it. Same goes for green, but here you can see that color G is 1. So on this part, the green value will increment. And the same counts for blue as well, except color.B is 2 here. So the blue color will increment, but by 2 every time. So if a LED is decided that it's going to change its color, then it will increase its blue color the highest, then it will increase its green value as well, and it will decrease its red value. That's how it gets its blue value. But the interesting part here is that, first of all, the LED value is not set immediately. It's continually changed, or gradually changed is more accurate to say, which gives it more like a fading effect. Not fading, but it's more soothing to look at. It's not abrupt and it's not very harsh, I guess. However, if the LED light is out of the range of the LEDs that we want to show, we do not instantly just set the value to 0 as we did. You can see as we did here in our code, we set all the values to 0, the red, green, and blue. No, we just decrement it by the fade scale. So, or we don't decrement it, we divide it actually. So it's kind of fast, but still it's not that fast. It's not so abrupt. So the fade scale here is 2, which means that we divide it by 2, and then we divide it by 2, and we divide it by 2 again. And eventually it's going to be as close to 0 as we can go. This is an integer value, so we won't have any floating values here. So this allows for an easy fade out if the LEDs are inactive or not being used because the sound value is low. Okay, so you can see we have 2 song modes here. So if you're in a high value, you can see the red is 5, which means that the red value will increment fast and the blue value decrease. So every time we change the mode, then we go from red, like a red yellowish sound, light, to a bluish sound. And the idea was that if a song is in its low point, where it's not taking off, or if it's building up, then the color is blue. But after, the bass drops or whatever, and there's a lot of sound in the song, and the song is in a high point, then the code can detect that. And this is what the check high function is for. So we can see this is the check high, and this is maybe the most complicated and ugly part of this code, and it desperately needs someone to care for it because it's hard coded and it's actually pretty ugly, but still it's one of the functions that makes this code nice. So what it basically does is it checks if the current average, the average value of the readings, if that is larger than the average sound of the song by now, then times 1.1. So if the current reading, the current average is higher than the song average, okay, then we enter this part. And this basically checks how many times we have reached this intersection. If we have been in this intersection before, then we can check the time value. So we check the current time and compare it with the time that we first entered this section. And if that's larger than 200 milliseconds, then we reset. We're back to normal song mode. But if not, we set a new millisecond time, and then we increment the times we've been in this intersection. Okay? And in the end here, we can see that if we have been in this intersection here more than 30 times, and the time that we lastly recorded the high value is less than 50 milliseconds, then we're in a high song mode, which means, okay, the song is pretty intense now, let's turn the lights red, or whatever color we want to turn them. And that's basically the interesting part. This other part here is just for setting it back to normal when we're not in a high mode anymore. So yeah, that has been the code walkthrough on the Sound Reactive LED lamp. I hope it cleared some things out for you, and if it didn't, you can always ask in the comments. If you like these kinds of videos, please consider supporting us on Patreon. You know, every single $1 will give you access to all future videos, walkthrough videos, and it will really help us out. Thank you so much for watching, and I'll see you next time.